Hello students, straight back again. Today we started on Chapter 7 notes. Chapter 7 titled Ionic Compounds and Metals. Today we'll be working on Section 7.1. Ion formation. As we continue on, Section 7.2 will be titled Ionic Bonds and Ionic Compounds. Section 7.3 will be a real key one for this, where we start looking at names and formulas. And in Section 3 we look a little bit more at properties of metals. So in Section 7.1, ion formation, some things you're going to need to be able to do. You're going to need to know what a chemical bond is. You're going to have to understand how positive and negative ions form, and relate ion formation to electron configuration. Old vocab, octet rule, atoms gain or lose or share electrons in order to get to that stable octet of 8 valence electrons. New vocab will be coming along too: chemical bond, cation, and anion. Key idea for the section: ions are formed when atoms gain, lose valence electrons to get to that stable octet electron configuration. Chemical bond, force that holds 2 atoms together. We're going to be looking at a number of different chemical bonds. In this chapter, we're going to be looking at ionic bonding. Another big one we'll be looking at is covalent bonding and some different types of covalent bonding. So, chemical bonds, attraction between nucleus of one atom and negative electrons of another atom. So we'll always try to get that, what we call the stable octet, by gaining or losing valence electrons. And here we're back electron dot structures for some different elements. And just as a little review, remember I want to see things like beryllium would be better as beryllium 2 dots, boron 2 dots together, single dot, carbon 2, and then 1 and 1. And the rest of them they have would be just how I would write them. Positively charged ion, called a cation. So a little illustration you have here. When we've got the neutral sodium atom, we've got 11 electrons, 11 protons. That's why it's neutral. And some energy comes in, causing an electron to be removed. So we got to add energy to pull this electron off. Then we have a sodium ion, which has 10 electrons, 11 protons, and then there's 1 electron out here, which then can be transferred to some other atom. So sodium atom plus ionization energy means we have a sodium ion plus an electron, so we have to add that energy. And many metals are very reactive because they can lose their valence electrons easily. And group 1, we tend to get this positive 1 ion. Group 2, positive 2. Group 13, positive 3. Transition metals very often will form 2+, 3+ ions, but they can form other things too, numbers greater than 3+. So they can have many different ionization states, and they get some things we'll call pseudo-noble gas configurations. Noble gas, or the transition metals, get these multiple charges because of the D sublevel. And here they're illustrating zinc. Zinc loses these two 4s electrons, leaving a complete D sublevel plus 2 electrons, so we end up with a zinc with the 2+ charge. Anions, negatively charged ions. That's a way you can remember the difference between a cation and an anion is a cation is positively charged, and an anion is a negative ion. A negative ion. Cation, T in the middle, like a plus. So here we got a neutral chlorine atom, 17 electrons, 17 protons, neutral. We bring an extra electron in. It then becomes 18 electrons, 17 protons, and releases some energy. So we get chlorine at plus an electron yields chloride ion plus some energy being released. Nonmetals typically gain electrons to fill up an octet. Sometimes they will gain or lose electrons to get an octet. Metals typically gain, nonmetals more often lose, but can gain too. Then we get group 15, common charge, 3-, group 16, 2-, group 17, 1-. A couple quick review questions. So oxygen gains 2 electrons, so it becomes 2- charge, and that makes it an anion. Elements with a full octet have which configuration? And full octet goes along with noble gas configuration. So there's a little overview of section 7.1. We'll do a lot of problems in class, as always. Till next time, this is Stripe.